So hello everybody, seems it's time to start, and we are talking about geometry project uh, from inscribed angles to cubic curves. This is, in my opinion, very nice geometry inside it. And okay, let's check, uh, let's make a brief presentation of it. So we start with the concept of isogonal conjugation, uh, the most easy case, isogonal conjugacy in angle or pair of lines, then isogonal conjugation in triangle. Most of these problems are known, but if you meet with them for the first time, it's not problem, you just can solve them. Then more interesting things with isogonal conjugacy in a quadrilateral, because not all the points of the plane has its isogonal conjugate. Now let us check this situation. Let A be A prime, B prime be quadrilateral, like in this diagram. And for this point X, there is point X prime, such that you see lines AX and AX prime are symmetric in the bisector of the angle BA prime. This green dashed line is a bisector, and these lines again AX and AX prime are symmetric, and the same happens for all four angles of this quadrilateral, and this red curve is the locus of points X such that there is isogonal conjugate X prime for them. So it's not all the plane, and we can try to move these points, and you see how this line, how this curve changes with respect of these four given points. There are nice equivalent things, nice equivalent properties for these points X. In other words, other descriptions of this locus, of this red curve. In particular, we can project the point X onto the side lines of our quadrilateral, as in this diagram, and see that all the projections lie on a circle. This one of descriptions. This a pedal circle for points X, and the same pedal circle will be for its isogonal conjugate X prime. Okay, this is symmetry in line BA prime, and we join X prime with this symmetric point of X and obtain this H as an intersection point, and draw a conic with foci X and X prime passing through H. This conic is inscribed in our quadrilateral.
синенькую точку, ну, серенькую, вот двиг, который, то XX штрих, он будет двигаться по подвиге.
Okay, we can try to move x and x prime, this pair of isogonally conjugates, and see how see this family of inscribed conics. Not all of them are ellipses. Next, we can join x and x prime and consider the midpoint. And the locus of these midpoints is a known Newton, or we used to say Newton-Gauss line. And basically, if we check our project, one of the main parts, the fifth part, is devoted to these properties of cubics of foci, or isoptic cubic. That's just another word, another name for it. You see many properties, and this Newton-Gauss line plays a great role. Now we present in the preliminary part only, say, half of this set of problems, but very soon you will see the other problems of this part. Okay, next return to the beginning. So part number 0 is about isogonal conjugates and polygons. Next, we introduce interesting transformations, and I'll try to show how do they work. We start with 4 arbitrary points, say forming a quadrilateral, and take any point x and draw circles like ax b, bx c, and so on, 4 circles. You see 2 new points of intersection. The circles AXD and BXC intersect in this new point. And we can consider transformation mapping X to this new point. We call such transformations isocyclic transformations. In fact, they are involutions. So if we go back from this new point to X, this is applying the same transformation. If we split 4 points into other pairs like A, B, and CD, and consider circles AX, B, and CXD, we obtain a new point. And it's very interesting that these 2 transformations defined above commute with each other. So if we again draw circles, these red circles in the diagram, they all pass through the same point, for a common point. And we obtain a nice picture, a nice configuration of, in fact, 8 points and 8 circles. The fact that these 4 red circles pass through common points, in fact, is equivalent to a known fact like Clifford theorem. But it's interesting to reformulate it in terms of transformations. We call these 4 points like X, these two blue points and this new point of intersection, the set of 4 points like 4 orbit. But these configurations have many symmetries. If we take these 4 orbit as the initial 4 points, then say A, B, C, D will be 4 orbit for them. So there are many nice properties, nice symmetries in it. And more interesting things if we split points A, B, C, D into other parts like A, C and B, D, and consider one more isocyclic involution. And if we apply it to point X and this 4 orbit, we obtain 4 more points, and this configuration will be okay. The picture will be, there is no picture with big number of circles on it. Okay, this is what we call 8 orbit, and some properties of these 8 orbits are also mentioned here. And more detailed study of them will be in the next part of our project. Not next, but in the 6th part of the project. It's interesting that one more circular transformation is naturally involved in this story, in this picture. This is about inversion plus reflection, interchanging pairs of points A and A prime and B prime. One can one can prove that the center of this inversion plus reflection is located in well-known Mikkel point of 4 lines A, B, B, A prime, B prime, and B prime A. And this is one of the key connections at problem number 2.3. With this inversion plus reflection could be split into composition of 2 isocircular transformation. In fact, this means that to obtain this red point from an initial green point X, we need to apply this inversion plus reflection transformation. Very interesting connection between transformation of different types here. And all these connections could be used further in studying our construction. The next part about special 6 states of points in the plane. On one hand, it is not very much connected with the other, but still some connection with the transformations defined above, and also with the further configurations is present. It's interesting by itself, but still there are nice connections with other parts. And next part is more not so elementary. It's about cubics, like cubic curves, algebraic cubic curves. And here we tried to start with initial basic definitions, how these curves are defined in Cartesian coordinates, and it's more convenient to define them in homogeneous coordinates on complex projective planes. And it's very amazing that these cubic curves connected with the previous mostly elementary geometry things, and in some problems maybe these curves is the most natural language, is most natural tool to study, to explore the problem. The one of the main things here is the definition of addition, the operation of addition. We define, it's a classical thing in algebraic geometry, when we defined how to sum two points, two regular points on a cubic curve. It happens that these operations have nice properties, and some of things purely in elementary geometry could be reformulated in terms of these operations, in terms of addition of points on certain cubic lines, cubic curves. Mostly we deal with special cubic curves like circular cubics. This is cubics passing through two special circular points on the complex projective plane. Any circle, our regular circle in classical geometry, extended to the complex projective plane, pass through these circular points. And some announcement about future main parts. I said something about this part is devoted to isoptic cubics mostly, and the sixth part could be considered in some sense. It is connected with all the other things we have here in this project, but it could be considered as a extension of the project, of the other project on the other summer conference of the Tournament of Towns, which was around between 10 and 11 years ago. Yes, 2010. And on this conference, we also use these kinds of transformation like reflection plus inversion, and they helped us in many difficult situations, like in many non-trivial problems. But in particular, one of the problems from this previous conference was not solved by participants. And the reason for this was maybe not using cubics. And now we return to parts of this project. Of course, we try to make it in a bit different way to generalize some things, but we return to it using this new tool, using cubic curves and operation of addition of points on it, and it is really helpful. It happens that it's really a good language to make nice and relatively short solution to difficult problems. So, well, maybe that's all about our geometry project. Of course, in the intermediate finish, we'll give some more detailed presentation of these main parts. We welcome you to start from the beginning, from part 0, 1, and so on. And of course, we expect you will need more problems, and we prepare these chapters 5 and 6 and more detailed presentation for them. And maybe one more thing, not very important, but maybe amazing. If you compare this English version with the Russian version, well, I try to compare here. You see a kind of epigraph, and we tried, but we failed to translate it in English. Now I will try to explain what is this epigraph about. So Alexei found this short abstract from Astrid Lindgren book. It's about when Carlson had broken some, as he used to do, he broke some toys, and they were discussing to play with toy cubes after that. So, but it's a kind of play of words in Russian, because toy cubes sounds like cubics, like cubic curves. And it could be formally understood that Carlson had broke the toys, and after that he's discussing, start with playing with cubic curves after that. Okay. Any questions, comments?
I have a question. If we were to pick this project, I was just wondering, because most of the literature and references were in Russian. So are they important to, solve the, because I don't know Russian. So
Yeah. Sorry for that. We just for this at this moment we just make like mostly copy and paste from this Russian, and I think it's not very important. It's good sources, but in Russian. But we try to put all essential things here, just here in this project. Of course, we try to improve this. Thank you for this request. We'll try to think about references in English, but we really try to put all essential things inside the project.
okay, thank you.
Well, and informal comment from me, myself, so, and I guess from the other authors. We have more students and we have a very good and I guess strong team of teachers and students here who will check your papers. And we all really enjoyed this geometry. This was new for me. So I know some parts of it separately, you know, and inversion plus reflection, like these things with Clifford construction. But here in this project, they are not separated. They're joined into a very nice picture. And we hope maybe you not only solve these problems and enjoy it, maybe you'll find some more connections. I have a feeling that it's very rich geometry in it. So we enjoyed and we welcome you to enjoy and to work on it. Okay.
I think I'll enjoy them too. Looks very nice.
Oh, Maria. Hello. Nice to hear.
Hello, Pavel.
So if there are any more questions, we finish our presentation for today. So dear participants, please choose your projects and solve problems. We wish you good luck, and please send solutions to the jury teams as only you solve problems. So good luck and have a good day. Good night.
Thank you.